Okay, so hi everyone. My name is Ayal, and I built IGOR for the last AI Hackathon. And today I want to tell you a little bit about my journey with IGOR and how, as someone who has no data science background whatsoever, I attempted and kind of succeeded maybe to build an AI assistant for Wix. So I want to share my train of thought, my dilemmas, my failures, my open-ended questions, and hopefully give you some food for thought and maybe even some inspiration for your own projects. Maybe you can even go and make IGOR some friends to play with. So what is IGOR? So you can think of IGOR as this black box that executes any kind of natural language Wix-related commands. Whether it's a stores-related command to update a product, or an editor command to add buttons to a site, or a business manager command to delete duplicate contacts. So this here is my vision of IGOR, and really the rest of the stuff inside the IGOR box is just implementation details. But after all, we're at an engineering conference, then obviously I'm going to mainly talk about those implementation details. But before the details, let's start with a demo.
How many products are there in the store?
There are 0 products in the store.
Create 3 video game products.
Done.
How many products are there in the store now?
There are currently 3 products in the store.
List the product prices.
Product prices, 49.99, 59.99, 39.99.
What's the most expensive product?
The most expensive product is The Legend of Zelda, Breath of the Wild, with a price of 59.99.
What's the average price of all products?
The average price of all products is 49.99.
Make a 20% discount on all products.
Done.
What's the average price of all products now?
The average price of all products is 39.99.
Delete all products from the store and tell me when you're done.
All products have been deleted. Deletion process completed.
Thank you very much.
Thank you very much.
So yeah, thank you very much. So after that demo, let's go ahead and dive a little bit into those implementation details. So what you see here is a more detailed view of the basic flow of IGOR. You have this natural language command coming in, and IGOR takes this Wix command and combines it with some context, and then sends all of that to a large language model. I'll say LLM from now because it's cool. And that LLM then generates code in JavaScript that is written using Wix APIs. And this generated code is then executed, and the task is done. So first I want to zoom in on the context part and talk a little bit about what this context looks like in IGOR. But even before that, let's clarify why do we even need a context? And by the way, I know that some of you might already be familiar with this and other subjects in this talk, but I want us all to be on the same page here. So I will try to quickly go over these kind of things. So LLMs can already write code. For example, I can ask an LLM to write code that adds 2 numbers. And it would do so very successfully. In fact, it can write much more complicated code than this. But the problem is that it wouldn't know how to write code that creates a product in a Wix store. Because it was never trained over such Wix-specific code examples. And that's what we need the context for in IGOR. So in IGOR, I use a technique called few-shot learning to teach a language model how to write code that executes the task that I give it. This is done by giving the LLM a few examples of what I would like its completion to look like given some input. The LLM can then generalize from these examples that I give it to complete other similar tasks. So what you see here is what the context in IGOR looks like. It's mainly this bunch of examples of command and the desired completion for this command. Now let me show you a couple of such training examples. So here's one example. The prompt is create a product of a t-shirt, and the desired completion is the code that does exactly that. As you can see, the code example here is using the Wix SDK. Here's another example. This time it's a query. What's the average price of all products? So you might say it's not a command, but for IGOR it's actually the same. It's just code using Wix API that completes the task of answering this question or query. Here's another example. I asked IGOR to create a blog post about superconductors. And this example uses a bit more than the Wix SDK. So the same way that I teach IGOR about Wix APIs, I can also teach it to use other APIs, in this case, OpenAI APIs, which makes IGOR quite a bit more powerful. So in the first version of IGOR, all these examples were hard-coded in the context. This was actually pretty cool already, and it produced super nice demos and super nice results. I could do almost any CRUD operation on stores or contacts or blog posts or what have you, just by giving IGOR a handful of examples from each domain, hard-coded in the context. But of course, if I were to present some vision of an actual product, I couldn't suggest this as a real solution. So I want to tell you about my first attempt at solving this, and it was actually not a very good one. So LLMs have this concept called fine-tuning. The idea in fine-tuning is that you train a model on exactly these kinds of Q&A pairs, prompt and completion, and then you end up with your own fine-tuned model that already knows what you taught it. It's like the context that I showed you is already inside the model. And indeed, OpenAI has an API for fine-tuning, which seemed like exactly what I needed and the way to go. Problem was that at the time of the hackathon, you could only fine-tune old models from OpenAI, like DaVinci, and not the newer models like GPT 3.5. And so my efforts actually yielded quite poor results, and I looked for another way to solve my huge context problem. I will say that as of August 22nd, you can fine-tune GPT 3.5, and this goes to show you what kind of moving target we're dealing with here. Also, I have to mention that I had to really hold myself back from implementing this new POC with the new fine-tuning ability, and instead keep working on this presentation, so I hope you appreciate it. It wasn't easy. And so I found my huge context solution somewhere else. Let's call it the notebook. So this magical notebook that I found in OpenAI's GitHub repo described a method for optimizing such huge prompts, and goes as far as to say that it might even be better than fine-tuning. You can call this method embedding-based search, and I will try to quickly describe it now. But first, what is embedding? Embedding is a numerical representation of some body of text that is used by LLMs to capture the semantic essence of a body of text. So a body of text comes in, and a vector, an array of number, comes out. And what is this embedding-based search method? So first you prepare your data. You take all those command and code examples, which are basically text, and you convert them into embeddings one by one. And then you store these embeddings in a database along with the original text. Then when the user gives you some command or query, you convert that into an embedding, and then the magic happens. You match the input command embedding with the stored embeddings in your DB, and this is how you determine which of the stored documents are the most relevant for the user input. Like, the important thing here is that those relevant documents that you get back would in fact be IGOR's new context now, because they are the most relevant to the user's input. So after implementing this, I can now theoretically keep adding these kinds of examples to this new part of IGOR, which would basically make IGOR smarter and smarter indefinitely, while still keeping my context trim and lean under some token budget. So my server implementation of this context optimization technique allowed me to also add this train button to IGOR's Playground app, and this way I can teach IGOR new tricks directly from the Playground UI. So moving on now, let's talk about code execution in IGOR. So I mentioned before, the output from the LLM is executable code in JavaScript using Wix APIs. But how do I execute it? So indeed, JavaScript has this built-in function called eval, which takes a code as a string and executes it. Did you know eval, by the way? But I knew it, but I was raised on the concept of eval is evil, and that I should do my best to avoid it, especially if the input is not controlled and that it's some kind of result of a user input, which is kind of our case here. So this whole part that I just showed you of me teaching Igor to generate code, I actually started by running away from it because of eval. So I want to tell you about this first attempt where I tried to teach Igor to produce something else, not code. So what you see here was my first attempt with Igor. I wanted to teach Igor to generate some JSON structure that would be sufficient to execute these Wix commands that the user wants to get done. And what you see here might work for creating a single product, for example. But what about creating several products? So you might say maybe change it to an array and then iterate. So okay, that could also work, but then what about queries like delete all contacts? So in this case, I would need to query all the contacts before so I can iterate them and delete them by ID. So then a new concept would need to be introduced here into this structure and then into the program that takes the structure and executes it. And it's a concept of some second request that is getting as input the response from a former request, and then probably also some concept of iteration. So you see, it's getting a little complicated. And that's not mentioning even more complicated concept of doing arithmetic or mapping and reducing. So you might be able to define such executable structures and write a program that executes them, but if you continue along this path, you're going to more or less end up with some kind of ASTN interpreter, right? It's almost like implementing eval. So, well, I certainly didn't have time for that in the hackathon, so at that point I decided to backtrack and I just went back to eval. But if I'm going back to eval, then the question is, how would you write a safe eval? And the answer is that you run it in a sandbox. I mean, Wix is not a stranger to running user code in sandboxes. And since Igor was actually implemented as a client-side app in the hackathon, that sandbox would be an iframe. And what do you know? I was actually very lucky because Igor's hackathon app happened to be written with the new Wix CLI, which already put me in an isolated iframe. And so after going full circle in this like little dance, for me this was a good enough reason to stick with eval. So let's continue, but still stay in the state of mind and the realm of how do you execute commands and code. So OpenAI recently introduced this new feature called function calling, and it immediately rang these bells regarding code execution and these dilemmas that I just talked about. But they introduced a slightly different and conversational and iterative approach, which is super interesting. And so I decided to like kind of branch out from Igor's main paradigm of this code execution and try it out. So the function calling flow is this kind of back and forth conversation with the LLM. First, the user sends a command to the LLM, and it's combined with some JSON schema that describes some potential functions that the LLM is allowed to call. Then, according to the user command and the schema, the LLM would ask us to call one of the functions we described in the schema, and then it's up to us to execute it and send back the response to the LLM, and so forth iteratively. So let's see a demo of that, and then break it down after. So I write make a 20% discount on all products, and then the LLM would ask me to call query products, and I run it in Igor. I get the response, and I send it back to the LLM. And then the LLM would just keep asking me to call update product again and again and again for each product with the correct ID and reduced price. And when it finishes to update all the 3 products in the store, it gives me this nice summary of its actions. So let's break it down in like slow motion. So in function calling world, instead of passing the LLM a context with the examples, I pass it a JSON schema that describes some function that the LLM may want to call according to the user prompt. So in the example of making a discount, I only pass two functions, query product and update product. Then the process begins. I first send my command to the LLM with this schema as part of the context, and what I get back is a request to call query product with no parameters. Then it's up to me to actually execute this function. So indeed, I created this mapper between the function names and their execution function. And as you can see, here I run query products and return the output. But what do I do with the response? That's right, I send it back to the LLM with all the previous messages and the whole schema and the user prompt. And then the LLM would look at everything, and that's right, it asks me to call another function now. This time it's update product with the correct parameters. So this is pretty amazing. It knows to use the correct ID from the first product in the response, and it also knows to calculate the reduced price. And it also knows to continue asking to call update product again and again and again. So this is a pretty amazing feature from OpenAI, which now also works in IGOR in this alternative version to code, complete code execution. And I want to try to compare these two approaches a little. So let's take a look at a few different aspects in code execution that code execution and function calling might differ. First, control. You already see that function calling might give you more control on what code runs and where. There is also more structure with function calling because the context here is very exact JSON schema, and it's not learning by usage examples. However, function calling is very wasteful in several senses. The first is that in each iteration that you just saw is a round trip to OpenAI, including all the schema and previous messages and the rest of that, whereas in code execution world, it's just one cycle of computation. Also, function calling is very wasteful in the sense that I have to introduce the response, I have to include the response JSON in query products in our case, in the payload to the LLM. So the LLM would know how to call update product with correct ID and price. So that's a huge payload to include. Also, who's making the calculation of this 20% discount? So in function calling world, the LLM does the math. I mean, an LLM doing math, I don't know about it. While in code generation, the LLM is actually writing code that does the math. And that's quite the difference. And when the code runs, it's a real computation. So that's a little bit to compare these two approaches. But there is another journey that this function calling demo sent me to that I want to mention. So for making the function calling demo, I manually created the schema, this JSON schema, for these two functions, query product and update product. But what I would have wanted is to auto-generate a JSON schema that is compatible with the Wix SDK, right? So as it turns out, Wix Schema API is actually exactly this schema of all of Wix APIs. This already exists in Wix, which was pretty cool to find out for me. And it also turns out that Wix SDK is auto-generated based on Schema API, along with things like Velo packages and ambassador packages. And so why not auto-generate a JSON schema as well to have it working with function calling? So I went on to try that too. And I was able to auto-generate a JSON schema compatible with the SDK. But it was a huge schema. It was thousands of lines of code. And I would have wasted all my tokens on just sending the schema. And so I thought maybe I can use embeddings to only choose the schema part that is most relevant to the user prompt. Okay, so maybe. I just didn't get there yet. For now, this is just food for thought. But actually, it made me realize another thing, something else that is unrelated to function calling. That even the code examples in IGOR's main paradigm, what I showed you before, they might become obsolete if the Wix API changes, right? So it made me think, maybe all those code examples should not be directly a part of IGOR. Maybe they should somehow be a part of the Wix API schema documentation. So it is all still very raw food for thought for now. Finally, I want to mention IGOR as a service. So IGOR started as a Wix CLI client-side app. Then the embedding part moved to a server. But the code execution still happened on the client. It was very coupled with the client app. And so one of the things, the last things that I did in IGOR to refactor is to refactor again and make it all work on the server. But that meant moving the evaluation of the code to the server, which begged the question, will all those Wix client examples get evaluated successfully and work on the server? Well, the answer was simply yes, with maybe a little bit of hacking. And then, in the serverless version, IGOR is just this big black box. A client passes the command to IGOR serverless, along with an authentication header, and the IGOR server would then just get everything done. And this finally proved to me that I wasn't lying. I wasn't just waving my hands in the hackathon presentation that I made to management when I said that IGOR can have any UX written on top of it, that it's not just that playground app. And actually the demo that you saw at the beginning of this presentation, where I talk to IGOR and it does what I say and it answers back, is written on top of IGOR serverless, where code execution is just an implementation detail. So thank you all very much. Really hope this was maybe an inspiration for your future projects. And if you have any questions, feel free to talk to me in Slack or email, or that thing that we sometimes do is that we talk face to face. You're welcome to do that too. Thank you.